Good day, students. Welcome to mathgotserved.com. And this clip we're going to be going over how to simplify radicals. We're going to be looking at how to simplify square roots and cube roots. This standard is covered in pre-algebra and algebra courses. Don't forget there are 21 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents covered. If you'd like access to the entire playlist and other valuable resources, take a look at the links in the description below, or you can just visit our website at mathgotserved.com. Alright, before we get started with the practice problems, we're going to do a real quick review of our squares and cubes. Okay, so let's write this down. Review. We're going to start with our squares. So in order for you to be able to easily simplify radicals, you need to remember what your squares are and what your cubes are, okay? At least for the first 12 numbers starting from 1. So let's look at our squares. What's 1 square? 1 square basically represents 1 times 1, okay? So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square, 6 times 6 is 36, 7 square, 7 times 7 is 49, 8 square, 8 times 8 is 64, 9 square, 9 times 9 is 81, and 10 square, 10 times 10 is 100. 11 square, 11 times 11 is 121, and 12 square is 144. Okay, so these are your squares that you want to have mastered so that you can easily compute the simplify radicals. All right, so how about our cubes? Let's take a look at our cubes starting from 1. 1 cube just means 1 times 1 times 1. All right, so the power repeats how many times you multiply that base by itself. So 1 to the third is 1, 2 to the third is 8, 3 to the third is 27, 4 to the third is 4 times 4, which is 16 times 4 is 64, 5 to the third is 5 times 5, which is 25, times 5 is 125, 6 to the third is 6 times 6, which is 36, times another 6, 216. 7 square, 7 times 7, 7 cube. 7 times 7 is 49, times another 7 is 343. 8 cube, 8 times 8 is 64, times another 3, that's 512. 9 cube, 9 times 9 is 81, times another 9 is 729. 10 cube, 10 times 10 is 100, times another 10 is 1000. 11 cube, 11 times 11 is 121, 121 times 11 is 1331. And then 12 cube, 12 times 12 is 144, times 12 is 1728. Okay, so these are the squares and cubes that can really help you compute the square root of radicals with ease. Alright, so the instructions for the examples that we're going to be working on are as follows. We have to simplify the following. So we're going to start with perfect squares first, okay, and then we will start working with squares that are not. We're going to be taking roots and cubes that are not perfect squares or cubes, and then we're going to be going over how to do those. Alright, so let's go ahead and simplify the following. For question number 1, let's say we have to simplify the square root of 121. This is a perfect square. The square root of 121 is 11 because 11 square is 121. Number 2, what is the square root of 4? Well, since 2 square is 4, the square root of 4 is going to be 2. Number 3, what's the square root of 81? Well, the square root of 81 is 9, since 9 squared is 81. Number 4, what is the square root? Let's look at a fraction situation this time. 16 over 25. So that's just simply the square root of the top divided by the square root of the bottom. So the square root of 16 is 4, and the square root of 25 is 5. Number 5, what is the square root of 36? Well, since we know 6 squared is 36, the square root of 36 is 6. Number 6, what is the square root of 900? Well, we have 9. We have the square root of 9 times the square root of 100, right? So the square root of two perfect squares, square root of 9, square root of 100, and then that's basically going to be 3 times 10, which is 30. Number 7, what is the square root, or let's say the cube root of negative 64? Now remember what 4 cubed is? Well, 4 cubed is 64. All right, and whenever you take the cube root of a negative number, the negativity remains, so the cube root of 64 is just negative 4. Alrighty, number 8, what is the cube root of 1? Remember, 1 cubed is 1, so the cube root of 1 is also 1. Number 9, what is the cube root of 343? The cube root of 343 is 7, since 7 raised to the third power is 343. Number 10, what is the cube root of negative 125? Remember, 5 to the third power is 125. Now, since we're taking the other cube root of negative 125, the negativity remains, so it's going to be negative 5, just as was the case with number 7. Okay. Number 11, what is the cube root of 1000? Cube root of 1000 is 10. Number 12, what is the cube root of 1331? Cube root of 1331 is 11. Okay. All right, so now let's go ahead and attack problems that are not perfect squares and go over how to find the square roots of those numbers, how to simplify those. Okay, number 13, what if we want to find the square root of 108? Now, this is not one of the perfect squares that we had on our list. So to do this, what we're going to do is basically break it down, okay? We're going to break it down into its prime factors using the factor tree, and then we are going to use the index to determine how to simplify that. Okay, so if you're simplifying 108, you just have to remember that this is a square root. There is an invisible 2 here. What does that mean? Well, if a factor repeats itself twice, that's a square, so it comes out as just the square root, which is one of them. Okay, all right, so let's go ahead and break down 108 into its prime factors. So 2 goes into 108. 2 goes in a 108 54 times, and then since it's even, 2 goes into 54 27 times, and then 3 goes into 27 9 times, and then 3 goes into 9 3 times. Okay, so having broken it down completely, we can now look for the perfect squares that we can extract. So 2 times 2, that's a perfect square, so these two 2's can come out as a 2. And then we have another perfect square here. 3 times 3 was the square root of 3 times 3. The square root of 3 times 3 is just 3. And then this 3 doesn't have a partner to come out with as a square, so that stays behind. Okay, so our answer is going to be the numbers that we could take the root of, which is 2 times 3. So this 2 times 3. And then this other 3 didn't have a partner to make a square with, so it stays behind. All right. So the final answer is 2 times 3, which is 6. 6 root 3 is the simplified form of the square root of 108. All right, let's take a look at number 14. So number 14, what if we want to find the square root of 75? Now, to find the square root of 75, we're going to break it down again. Remember, we have an invisible 2 as an index right here, so every pair comes out as 1, okay? So what goes into 75? It ends in 5, so 5 goes in it for sure. 5 goes into 75. 5 goes into 7, 15 times, and then 5 goes into 15 3 times. So what repeats here? You notice that we have a perfect square here, 5 times 5. So the square root of 5 times 5 is just 5. So this 2 break out as 5. And then this 3 stays behind. So your answer to the square root of 75 is the 5 that came out, root the 3 that didn't have a partner to break out with as the root of a perfect square. All right, let's take a look at number 15. Number 15, let's say you're looking for the square root of 63. That clearly is not a perfect square. It's pretty close to 64. What's the square root of 63? Well, we're going to follow the same procedure. Let's go ahead and break it down. 3 goes into 63 because the sum of the digits, which is 9, is divisible by 3, so that number is divisible by 3 also. 3 goes into 63 21 times. 3 goes into 21 7 times. Okay, so we have a perfect square here, 3 times 3. So what is the square root of that? Square root of 3 times 3 is just 3. 7 is not a perfect square, it's just one factor stays behind. So the square root of 63 is 3 root 7. Alrighty, moving along, let's take a look at question number 16. So for question 16, let's say we want to find the square root of 162. All right, we're going to use the factor tree to break this down. So square root of 162. 162 is even, so we can take a 2 out of it. So 2 goes into 162 81 times. Okay. All right, so for this one, let me show you a nice little shortcut that you can use. 81 is a perfect square. So if you end up with a perfect square when you're breaking it down, you can take a real quick shortcut. So instead of breaking this down completely, we can just break it into its roots. What is the square root of 81? Well, 81 is 9 times 9. Alrighty, so what that helps me to do is I have identified a perfect square without breaking it down completely. So this 9 times 9 comes out as 9, and this 2 stays behind because it doesn't have a partner to break out with. So this becomes 9 root 2. Look at question number 17. So for question 17, let's say we want to find the square root of 320. Alrighty. Alright, so let's do that. So the square root of 320. Now since 320 ends up with a 0, that means 5 goes into it. 5 goes into every number that ends with a 5 or 0. Alright, 5 goes into 32 6 times. 5 goes into, to carry over to 220 4 times. Okay, and then take a look at what we have right here. 64 is a perfect square, so we can use the shortcut that we use in number 16. Just break it down into its roots, which is 8 times 8. So we have a perfect square there, so we can see that these two will come out as 8 because that's a perfect square. The square root of 64 is 8, but this 5 is not a perfect square, so it stays behind. So the square root of 320 is 8 root 5. Let's take a look at question number 18. For question 18, let's say we want to simplify the square root of 363. Let's do that. So square root of 363, let's break it down. Let's add the digits. 3 plus 3 plus 6 is 12, which is divisible by 3. So we know for sure that 3 goes into 163. All right, if you divide by 3, you have 121. Voila. Ladies and gentlemen, we have a perfect square. So we can just take a shortcut here and just break it down into its root. 11 times 11. So these two can break out. Square root of 11 times 11, or square root of 121, is 11. Okay, so the final answer here, oh, the 3 doesn't have a partner to break out with, so it stays behind. The final answer is going to be 11 square root of 121 times the square root of 3, which was not able to break out. Alrighty, let's take a look at the next one. Question number 19. For question 19, let's say we were to find the square root of 180. Alright, so let's do that. So square root of 180. So let's go ahead and see how we can break this down. So it's even, well, it ends up at a 0, so we know 5 goes into it, right? So 5 goes into 180 how many times? 5 goes into 80, 18, 3 times, 15 namely. And then carry over the 3, 5 goes into 30, 6 times. Oh, look at this. We have a perfect square. So we can just use a shortcut and break this down into its root, which is 6 times 6. Whenever you have a perfect square, that's how you do it. All right, so these two repeats. That means that they break out as a 6. And then 5 stays behind because it doesn't have a partner to make a perfect square with. So the answer is 6 root 5 as the answer to question number 19. For question 20, let's say we were to find the square root of 320. All right, let's modify that. We already did 320. Let's do, how about make it 300? Okay, so let's find the square root of 300. All right, so let's go ahead and do that. So finding the square root of 300. If you add the digits, 3 plus 0 plus 0, 3 goes into that evenly, so no 3 goes into 300. 3 goes into 300 how many times? 100 times. Well, this is spectacular because we have a perfect square as one of the factors. So to save time, we just break it down into its roots. We know that 10 times 10 is 100. So now we can know for a certainty that these 10 times 10 that repeats in the decomposition of 320 can come out as its root, namely 10. And then this 3 is not a perfect square, so it stays behind. Final answer is going to be 10 rad 3 as a simplified form of the square root of 300. Okay, moving along, let's take a look at question number 21. So for 21, let's say you're looking for, let's do a cube root problem this time, okay? So let's say you're looking for the cube root of, let's say 54, for example, okay? So now we have a different scenario here, alrighty? In this particular case, the index is 3. What does that mean? Well, it means that every factor that repeats itself 3 times, the product of a factor 3 times, is a cube, and that could break out of the radical, the cube. Alrighty. For squares, we needed pairs to break out. For cube roots, we're looking for triples. Trios for triples and duos for square root. What am I talking about? Well, let's break it down so you can see exactly what I'm talking about here. 54 is even, so 2 goes into it. 2 goes into 54 27 times. Now, if you remember, 27 is a cube. Okay? Do you remember what the cube root is? Well, let's break it down so you can see what it is. So if you break 27 down, 3 goes into 27 9 times, and then 3 goes into 9 3 times. Now for the cube root scenario, we're looking for triples, a factor that repeats itself 3 times. Why is that? So look at this right here. This is significant, 3 times 3 times 3, because the cube root of 3 times 3 times 3, or 27, is 3. So you need the triple to break out like we have here. This 2 needs 2 more factors, identical factors of 2 to break out. It doesn't have it, so it stays behind. The final answer for 21 is 3 times the cube root of 2. That's a simplified form of the cube root of 54. All right, so how well did you understand or master the presentation that we just went over? Well, we have some practice problems that we'd like you to try out in order to demonstrate mastery. All right, so we have 21 practice problems that we'd like you to try out. So what you would like you to do at this time, go ahead and pause this video presentation. Try out these 21 problems, and when you're done, click back on the play button to see what the answers are. Alrighty, so hopefully you had a chance to try out the problems. Let's take a look at what the answers are. Answers coming up for number 1 is 13, number 2 is 5, number 3 is 16, number 4 is 3 over 8, number 5 is 7, number 6 is 10, number 7 is 4, number 8 is -3, number 9 is 5, number 10 is 6, number 11 is -1, number 12 is 9. Now this one you have to break it down, okay? Number 13 is 5 root 2. Number 14 is 6 root 6. Number 15 is 2 root 7. Number 16 is 8 root 3. Number 17 is 9 root 5. Number 18 is 2 root 11. Number 19 is 15 root 2. Number 20 is 5 root 7. And number 21, the cube root of 320, is 4 cube root of 5. Alrighty? So how well did you do with these practice problems? Well, let us know in the comment section below how well you did. If there are any questions or clarifications that you like on any of these problems, just specify it in the comment section. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your studies of radicals and exponents too, do give us a thumbs up. Your positive feedback or like is very valuable to us. If you have any questions or comments as specified earlier, just post it in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our channel. Sorry. Don't forget to hit the subscribe button to subscribe to our channel. We upload videos to our page on a regular basis. More support resources can be found in the links in the description below, or just visit our website mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.